All right, let's take a look at how do we construct a confidence interval for a population mean when we happen to know the population standard deviation. So we know the value of sigma. We know how the data values in the entire population are distributed relative to the mean, even though we have no idea what that mean is. All right, so here we need to just make sure that we know what our notation represents. So that mu, that is a population mean. The x with a bar over it, that is our sample mean. We have sigma, that is our population standard deviation. And we have the value n, that is our sample size. So we will use each of those when we go and try to calculate a confidence interval using StatDisk. So how do we do this in StatDisk? Well, we need to check that the following things are satisfied. So the first thing that we should check is make the observation that our sample is a simple random sample. If that is not the case, then we can't roll through this. We don't have information that would tell us something about the entire population because that sample was taken not in a random fashion, but instead in some sort of biased fashion. Then we need to check to make sure one of the other two things is satisfied. So either the population needs to be normally distributed, or if it's not normally distributed, you need to have a sample size greater than 30. So when we have a sample of 15, we can use these methods to come up with a confidence interval, provided that the initial population was normally distributed. All right. If we have a population that is not normally distributed, if we have 37 things in our sample, then we can still use these methods because our sample size is bigger than 30. So one of those two things have to be true. You could have both of them true. Then we want to identify a number of different things. So we want to identify the confidence level. We want to identify the sample size n, the sample mean x bar, and we also want to identify the population standard deviation. All right, so we will identify those four different things. We choose analysis, confidence intervals, and then mean one sample. And then we will input each one of those four items again. Right? So we input the confidence level, we input that sample size n, we input the sample mean x bar, and we input the population standard deviation. The sample standard deviation here, we don't have it, or we might have it. That's really just extra information. We don't need it in this case. So we do not need the sample standard deviation. All right, so let's take a look at an example. A random sample of 40 Chips Ahoy cookies found that the mean number of chocolate chips was 24 chocolate chips. Data suggests that the standard deviation in the number of chocolate chips in all Chips Ahoy cookies is 3 chocolate chips. All right, so here, that 40 right there, that is our sample size. Right? That is the number of Chips Ahoy cookies that we have in our sample. Right, so n is equal to 40. This random sample found that the mean number was 24. Right? So that mean number, we found that to be 24. That is our value of x bar. X bar is equal to 24. That information is written in the sentence along with the random sample. So if I were to take out some of those extra words, a random sample of 40, blah, 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 found that the mean, blah, 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 was 24. So random sample of 40 found the mean was 24. Then we have this next sentence that says, data suggests that the standard deviation in the number of chocolate chips in all Chips Ahoy cookies, is 3. So that is a standard deviation. But we need to identify, is this the standard deviation of the sample or for the population? And it's for the population, because this standard deviation, it is the standard deviation in all. So the standard deviation in all Chips Ahoy cookies is 3. It's talking about the entire population. All right, so now let's answer some questions regarding this. So first up, we have, what is the best point estimate for the mean number of chocolate chips in all Chips Ahoy cookies? If you can only choose one number to try to guess what is the mean number of chocolate chips in Chips Ahoy cookies, based on the information you have, what number would you guess? And our best point estimate, the mean in the population, I'd say it's 24 chocolate chips. So in the sample, the average, the mean was 24. So I'm guessing for the population, if I can only choose one number, my guess is it's 24. That's probably not the right number. That's why we take from this point estimate, we build out a confidence interval. We get this interval of values that we have a lot more confidence in. So now we want to find a 95% confidence interval. So now we're looking for a 95% confidence interval. So our confidence level is 0.95. Our sample size is 40. Our sample mean is 24. And our population standard deviation is 3. All right, so let's go to StatDisk and take a look. So here in StatDisk, we are going to choose analysis. Down here, if we go down a little bit, we get to confidence intervals, and we choose that, and we are dealing with a confidence interval about a mean, and we only have a single sample. So our confidence level is 0.95. Our sample size here was 40, so I'm going to change that to 40. Our sample mean, that was the mean from the sample, that was 24. The sample standard deviation, we were not given that in our information. I'm going to try leaving it blank. If I have a population standard deviation and I have a sample standard deviation as well, the population standard deviation will actually take precedence. And so we have 3 here. I'm going to see if this works. Let's see. Yeah, so that works fine. And so what does this spit back? It spits back a confidence interval. All right, so 23.07 to 24.93. The margin of error that was calculated there was 0.93 chocolate chips. Right, so we can go back there and take a look at that. Right, so up there, 0.929. So if we rounded to the second decimal point, we have 0.93 chocolate chips. Can we confidently say that the mean number of chocolate chips is greater than 23? Can we say that confidently? Yes. Why? The entire confidence interval is above 23. Can we confidently say that the mean number of chocolate chips is less than 26? Well, sure, we can say that as well. Right? Why can we say that? Well, we can say it's less than 26 because the entire confidence interval right here is below 26. Could we confidently say that the mean is less than 24.7? No, we could not say that because 24.7 occurs somewhere in between our 2 endpoints for the confidence interval. All right, Next time, we'll take a look at finding confidence intervals when the population standard deviation is not known. All right, we'll talk to you then.